Hi everyone. Yeah, we're slightly behind schedule, so I adjusted the homework and quiz due dates and the exam. So homework 4 is due tonight. And remember your homework, you can continue to work on it even though it's all after the due date, you can still resubmit to improve your scores. Right. So I just need your first attempt to redo before tonight. Okay? And you can continue to do more attempts. And then next homework 5 and quiz 3 is gonna be next Wednesday. Exam 2 is the Wednesday, October 25th. And because we postponed the homework and exam dates, and our semester must finish within 16 weeks. So which means you have a 1 week that you have 2 homework due and a quiz. Okay? And your exam 3 is within 2 weeks. Because exam 3 only covers 3 sessions. That's why it's so fast. And then, yeah, your exam 4 is here. Your homework 10 is right after the exam 4. So that's why I hope you can do your homework like every night. Don't wait until the due day to start your homework. Yes. Okay. That's the plan. And so today we continue to finish 4.4 and 4.5, right? And remember the rule of exponential function? Derivative of e to the x is e to the x. Derivative of e to the kx is k e to the kx. Remember how it looks like the sun? The motion is like the k, right? And derivative of b to the x is b to the x times l and b. Okay, we multiply by l and b. That's the exponential function. The logarithmic function, the natural law, the derivative is 1 over x. Okay, everybody? The reciprocal, 1 over x. And then the derivative of absolute value of x is also 1 over x. And if you have a other base, like log bx, okay? Log bx. Why we get this? Because the log property. Do you remember the log property? So what are the log property? We have ln p plus ln q is ln of p times q, right? Everybody? And ln of p minus ln q is ln of p over q, right? And if you have ln of p to the m, you can move the m down in front. Yes? And we also have the change base formula. So log bx, let's say we want to change to base e, is ln of x over ln of b. Okay, everybody? So you can change with any base. Your x is still on top, your b is in the bottom. Right? This is change of base formula. That's why the derivative of log bx is, see, the constant coefficient is like 1 over ln b, and then the derivative of ln of x is 1 over x. That's why you get this formula. Okay? Yes. And keep in mind, the derivative of exponential function, you multiply by ln b. The derivative of the inverse function, the logarithmic function, you divide it by ln b. Okay? So multiply, divide. Yes. So remember the formula, just like your name. Okay. Let's do this. So when we take the derivative, it's like onion. We look at the outside and then the inside. The outside is, see, it's ln of something, right? So this is a composition. Well, for composition, what is the derivative of ln u? What's the derivative of ln u? 1 over u times g root times same rule is whatever formula is before, you multiply by u prime at the end. Okay? So 1 over u times u prime. And even though we say u, but we actually write down what the u is. So 2 ln x plus 3 and... Okay. This is x to the what power? 4/5. Yes. Okay. So 1 over u times u prime. Okay, everybody? Alright. So we keep going. This factor has no prime. We just copy it. Okay? And then this factor has prime. We need to differentiate. Okay, one by one. 2 ln x. What's the derivative of 2 ln x? Derivative. Yeah, this is ln x squared, but you want to check the derivative. So 2 is constant multiple. It stays here, right? Then the derivative of ln x is... What's the derivative of ln x? 1 over x. So 2 times 1 over x. Yeah, constant multiple stays here. And derivative of ln x is 1 over x. Is that okay, everybody? So remember to watch the recording for the first 6 minutes. Okay, we talk about the homework due date. Huh? Oh, this is 4.4 and 4.5. Yes. And we talk about our class schedule, your homework due date. Okay, and then next, the derivative of this is what? Blank? Yeah, very good. Right, everybody? Okay. Yes, you can leave your answer like this, or you can multiply the 3 and 4. You get 12 over 5. Okay? So as long as you have all the prime disappear, you finish taking the derivative of it, then you can stop. You don't have to simplify. So far, so good? Okay. Any questions about part B? No? Okay. So keep going. Here we have 2 to the ln 3x and e to the square root of 1 minus x. Remember, we look from the outside to the inside. What's the outside format? You have something times something. So this is something times something is what's that word? Sorry, the P. Product, right? So in the format, it's something times something. It's a product. So we use product rule. Okay? Each step, we only do one thing. So Will, what is product rule? What is product rule? Remember to students go to the restroom? Okay. Do it slowly. So you have the first factor prime. Okay, don't take the derivative of that factor yet. Just write down that factor. First factor prime. Yes. And then what? Square? A square root, yes. And then? Plus or minus? Mm-hmm. Yes, 2 ln 3x. And then? Yes. See? Every step, we just do one thing. Don't skip the steps. It's very easy to make mistakes. Okay. So this time we only use the product root. And then the next one, we're gonna differentiate this factor. Right? Look at the format. 2 to the something. So this is a competition. Right, everybody? By the way, can we cancel 2 and ln? No. 2 is base 2. ln is base e. They don't have the same names. We cannot cancel. Okay? So here we look at this. This is a composition function. This is the u. What is the derivative of 2 to the u? Two to the u. Father looks like the sun. Father has mustache. Look at the first page. What's the derivative of 2 to the u? Here. If you have other base, then you use this formula. 2 to the u derivative is 2 to the u ln 2 times u prime. Yeah. Okay, everybody? So if you're not familiar with the formula, write this formula down on a piece of paper and then review the formula every day. Okay? Yes. Because knowing the formula is the basic, the first steps. If you don't know the formula, then you get stuck. Okay. So 2 to the u. What's u? ln 3x. And times 2 to the u times ln 2. Right? Yeah, 2 to the u times ln 2 times u prime. Is that okay, everybody? 2 to the u times ln u. Sorry, ln 2. 2 to the u times ln 2 times u prime. Okay, remember this is the mustache. ln 2. Yes. Okay. And then next we have e to the square root of 1 minus x plus 2 to the ln 3x. Chain rule. Chain rule. If this is 2 to the x, then you use 2 to the x ln 2. That's it. But this is not x. This is something else. You have a composite function. Then you let u be the inner function. Then the formula is the old formula. You multiply by u prime at the end. Remember chain rule? Yes. So, okay. And next, see, we have e to the u. Page, what is the derivative of e to the u? E to the u? Yes, stay the same. E to the u, but then times what? The u prime. The u prime. So do it slowly, okay? Here we're using chain rule. So it's the old formula, you multiply by u prime at the end. Is that clear, everybody? So be familiar with all the formula. Okay, the factor with no prime, just copy it. But then the factor with the prime, we need to take the derivative. Okay, see, derivative. We have ln of something. So this is like u. Questions? Yes, you're right. Thank you. Sorry, I look at the 3x and then I put down the 3. Yes. Right. Okay. Alright. And now you see it's ln. We have the formula for ln x. But this is not exactly x, right? If it's not exactly x, we need to use chain rule. It's a composition function. And ln u derivative is what? Mackenzie. Ln u derivative is ln u. Derivative of ln u is what? Derivative of ln u is what? 1 over u. Yes. 1 over u. So 1 over u. U is 3x, right? 1 over u times u prime. Is that okay, everybody? There is another way to solve the derivative of ln 3x. You can think of this way. So ln 3x, you use log properties, is ln 3 plus ln x. Right? You can separate the product into sum of log. Okay, now when you take the derivative, do you see derivative of a constant is 0? Derivative of ln x is just 1 over x. So therefore, see, what's the derivative of 3x? It's 3. This 3 is in the numerator. This 3 is in the denominator. They cancel. So you get 1 over x, which is the same with, if you think of this way. Okay, so you either use the log property, then you don't need to do chain rule. Or you use chain rule, and then, yeah, you get the same answer. So you can think of this in 2 ways. Okay, keep going. So we have e to the square root of 1 minus x, and then plus 2 ln 3x. We just copy it. Okay, this guy. We have the square root of 1 minus x. See, this is not exactly the power function, right? So we need to use chain rule, right? This is what? 1 minus x to the 1/2. Okay, see? We let u be 1 minus x. What is the derivative of u to the 1/2? Gabby. What's the derivative of u to the 1/2? Power rule? Yes, 1/2 u, so 1 minus x to the negative 1/2 times u prime, which is, yeah, negative 1. Good. Finally, let's rewrite it one more time. So 2 ln 3x, ln 2, and this is 1 over x, and this is e to the ln, e to the square root of 1 minus x. And then the minus, we can move it in front. So minus, I can also move the 1/2 in front. 2 ln 3x, e to the square root 1 minus x.
And then this is 1 minus x to the negative 1/2.
So this is the answer. Question. Can I cancel this 2 and this 2? No. Okay? We cannot cancel this. Alright. So you can leave your answer like this. So yeah, you see this problem is more complicated. We first use product rule, and then here we use chain rule, and then you use chain rule again, right? And then here we use chain rule, and then we use chain rule again. So we use chain rule 4 times and use product rule 1 time. Okay? So for derivative, any function you can always find its derivative. It's just the process. If the problem is complicated, then the process is long. So you look at it from the outside to the inside, and you do it step by step. Each step just do one thing. Okay? And for the factor with no prime, just copy it, and then you look at the factor with prime, you differentiate. Okay, everybody? Mm-hmm. All right.
And then part D. Okay, so this one, what's the format from the outside? You
Look at the format from the outside and inside. You have this times this, so it's products, right?
So we use product rule for the first step. What's product rule? Yeah, u prime multiplied by v, and then plus u v prime. Yes. Is that okay, everybody? All right. Oh, look at this guy. This guy is like 5e to the 4x minus 7 to the what power? Yeah, 1 over 3. And we want to take the derivative of this. So, George, what do we use? What rule do we use? Yes.
This something to the 1/3. What rule do we use? So okay, look at the format. Something to the 1/3 power, right? This is a power function. But the power function we learned is just x to the some power. But this is not x. If this is not x, then we need to use chain rule because it's a composition function, right?
So we call the inner function be u. And then this is u to the 1/3. What's the derivative of u to the 1/3? Okay. Everybody take out a piece of paper. Okay, so take out a piece of paper. Everybody take out a piece of paper. I think you're still not familiar with all the all the derivative formula. So let's review all the derivative formula that we learned in this chapter. So take out a piece of paper. The first rule we learned is the power rule. Okay? What's the power rule? N times x to the n minus 1. Right, everybody? And then we learned the product rule. So product rule, uv prime is u prime v plus ue prime, right? Yeah, write it down. And then we learn the quotient. What's the quotient rule? U prime v plus or minus over v squared, right? So we learn power function, we learn product rule, we learn quotient rule, and then exponential function. E to the x derivative is what? E to the x, right? E to the kx derivative is k e to the kx, right? And then the harder one, b to the x. B is any number. What's b to the x derivative? ln(b) times b to the x. Right, everybody? And then the logarithmic function. ln x derivative is what? 1 over x. And then log bx derivative is, remember, same as before, but you, what? Divided by ln(b). Is that okay, everybody? So this is the rule. You need to memorize it like your name, okay? So if you have trouble memorizing it, come to see me. Let's make up some story. I already made a story here, like two students go to restroom, right? And this was five little slices of sun. Father has no such. Yes? This one? E to the x is e to the x. The exponential function, the derivative of the exponential function. Yes. And the chain rule, when you see composition function, okay? If you see an inner function and an outer function, then it's the old formula, and you multiply by u prime. So this is the chain rule. Okay? So these are all the formula we learned in this chapter. Okay? So Josh, again, u to the 1/3 derivative is the power rule. So what's that? What's n? So look at from the outside. Don't look at the inside. Don't let the 4x and 7 confuse you. Look at the outside. The outside is something to the 1/3, right? So always look at from the outside to the inside. Like, how do you peel an onion? Do you know what it looks like inside the onion before you peel out the first layer? No! You peel the first layer, so the first layer is like a product. You use product rule. Don't look at the things inside, okay? And then this step, look at the outside. It's something to the 1/3. The 1/3 is what is important, right? So we use the power rule. What is the derivative of u to the 1/3? Times what? Times the u to the, yes, and then times, remember, chain rule, you multiply by u prime. Okay, it's the old rule. You multiply by u prime at the end. Okay, everybody? So
Imagine we peel off the layer of the onion. You don't know, maybe the inside is bad or good. We don't know yet. So you have to peel off the first layer and then the second layer. Then you can look at inside, right? Yes. Don't let the inside part confuse you. Look at from the outside to the inside. So this is the derivative of the first factor, right?
And then the second factor we multiply. Right? The second factor has no prime. We just copy it. And then plus, do you see this guy has no prime? We copy it. Okay. So we copy it. All right. Next, Layla.
What's the derivative of this?
The things inside, right? 2x to the fifth plus 3x. And then yes, it's 1 over u times u prime. Okay, everybody? So, yeah, this paper, okay, this sheet of paper, remember this, okay? Every day, remember this rule. Remember this rule, okay? All right, good. Let's keep going. So we have 1/3 5e to the 4x minus 7 to the negative 2/3 multiplied by,
What's the derivative of 5e to the 4x? Now, Jay, what's the derivative of this?
yes, right, everybody? And derivative of 7 is 0. Okay, ln 2x to the fifth plus 3x. So with no prime, we just copy it. It could be complicated, but it's okay. We just copy it. You don't need to simplify. And then, but don't forget your baby, okay? If you have the baby parentheses, then when you write it down, include the parentheses, okay? What's the derivative of 2x to the fifth? Blaine. Plus what? 3. Yes, very good. Yes. See? Now we get rid of all the prime. Then we are done for this problem. Okay? So be familiar with all the derivative rule. Okay. Example 2. We want to find the equation of the tangent line for f of x is square root of e to the x plus e to the square root of x. Okay? We need to take the derivative. Okay, let's see. Let's put this in the standard form. So square root is what? It's like this thing to the 1/2. Do you agree? And plus e to the square root is x to the 1/2. Right, everybody?
Oh, can you simplify this? What do you do to the exponents? Add them? Do you add the exponents? We multiply, right, everybody? We multiply them.
So this is e to the 1/2 x plus e to the x squared.
See where your square root located? They mean different things. Okay, so this is the standard form. We're ready to
Differentiate. Do you remember how to find the tangent line? You take the derivative, and then you plug in the x value to find the slope of the tangent line. And then you also need a point, right? How do you find the point? You have the x coordinate, then you plug in a function to get the y coordinate of the point. And then with point slope form, you can write down the tangent line equation, right? If the problem asks you to find the normal line is perpendicular to the tangent line. So your slope of the normal line will be negative reciprocal of the slope of the tangent line, right? Yes. Okay. So what is the derivative? What's the derivative of the first term? Do you know that? E to the 1 half x. E to the 1 half x times. Father looks like the son, but father has what? Times 1 half. Exactly. That's the mustache. Right, everybody? Times 1 half. Okay, plus the second term. Do you see the second term? We actually need to use chain rule because this is not x. It's x to the 1 half, right? So what is the chain rule? E to the u derivative is e to the u times u prime. Yes. U prime. Okay, everybody? So a typical mistake is students will put the u prime here. No, u prime is always at the end by itself. You multiply the u prime at the end. Okay. Page. What is the derivative of x to the 1 half? X to the 1 half derivative is yes, negative 1 half. Right, everybody? Power rule. Okay, so this is the derivative. We want to find the tangent line slope. Well, that's the derivative. We plug in x is 1. See, everybody? We plug in x is 1. So we get 1 half. E to the 1 half times 1 is 1 half. Right? Everybody? Plus e to the, what is 1 to the 1 half? The square root of 1 is 1, yes? And e to the 1 is just e, right? And then multiply by 1 half. Oh, and 1 to the whatever power is just 1. Right, everybody? Yes. So this is the slope. Okay. By the way, here we're not able to simplify because e to the 1 half and e they're not like terms. You cannot combine them. Okay, everybody? It's like x squared and x. They're not like terms. You cannot combine them. Okay? So we have the tangent line slope, and we also need to find the points, right? The y coordinates is what? So f of 1 is what? I just put the y coordinate of the point is f of 1. F of 1 is square root of, you see this formula? This is f of x. We plug in x is 1. E to the 1 is just e, right? And then e to the, what's square root of 1? 1. Oh. So this is my y coordinates. Is that okay, everybody? Yes. Even though they don't look nice, but it's okay. Use the point slope form. Y minus the y coordinates equals to the slope. Your slope is this. Okay. And e over 2. Can I put e over 2 instead of e times 1/2? Remember point slope form? Y minus the y coordinate of the point equals to the slope times x minus the x coordinate of the point, which is what? 1. Yes. Very good. Okay. And you can solve for y. So you can solve for y. I would say you can both sides add this thing, right? You can both sides add this thing. Then y equals, you can also distribute. See, when you distribute, you get 1/2 e to the 1/2 plus e over 2 times x. And then I want to minus 1. Okay, minus 1 times this guy is negative 1/2. E to the 1/2 is the same as square root of e. And then minus 1 times e over 2. Is that okay, everybody? I use this whole thing times x minus this whole thing times 1. And I want to break the parentheses. So I get minus and minus. And I want to add this. So add square root of e plus e. Okay. The x, I don't want to distribute the x because I like to have something times x. So then I know this is the slope. Okay. But this, for the constant, I can simplify. Do you see square root of e and minus 1/2 square root of e? You get 1/2 square root of e. Yeah. So we get positive 1/2 square root of e. And then minus 1/2 square, 1 minus e over 2 plus e is question.
Is it possible to change the e to the 1/2 in
Yeah, sure. Of course, they're the same. Yes, if you like to change this, you can also change this. Yes, and then the e minus e over 2 is e over 2. So this is a answer. Okay, this is a tangent line. So far, so good, everybody? Yes. So, and then we finished chapter 4. Okay, so your exams is about 4.1 to 4.5. Okay, so that's what is going to be on your exam. And let's see, do you want to like look at the practice exam together and then you know what type of problem is going to be on the exam? Okay, so this is a practice exam too. Like last time, I hope you do the practice exam using pencil. And then you look at the solution, use red pen or other color pen to make corrections and estimate your scores. So make sure you write down the corrections. If you see a mistake, write down the corrections. You need to know what is the correct way to solve the problems. So number 1 is you take the derivative, right? So like what we have been doing, you take the derivative and, oh, this problem. Do you see the 3? You can use the Allen property to move the 3 in front. Then you take the derivative, it will be easier. And then here, yeah, see, so you need to use chain rule. And this one, look at the format, something times something. This is product rule, yeah, and then use chain rule. How about this? Something times something, also product rule, and then chain rule. And then here, something to the 4/9. Quadrant rule? Quotient rule?
Power is something to that power is chain rule.
Yes. And then how about this one? Quotient rule. So quotient rule first, and then inside the quotient rule, you might need to do chain rule. Okay? How about this one? Chain rule. Yes, something to the 1/2 chain rule. Okay. And then problem 2.
See, you need to take the derivative and then you plug in the x values to find the tangent line slope, right? And then normal line slope is what? Negative reciprocal of the tangent line slope.
Right. Okay. And how about this?
Find the x values for which the tangent line has slope 7. Slope is what? The derivative. You take the derivative and you set the derivative is 7 and you solve for x. Do we plug in x is 7? No. Right, everybody? So that's the slope, that's the derivative. Derivative is 7 and then you solve for x.
Okay, how about this?
You have the cost function and x of x is the price, the sale price per item if x items are sold. Then the profit, so I give you the formula, which makes sense, right? The money you earn, so you sell x items. Each item is x dollars. You multiply them, this is the amount you earn, right? And you need to subtract the amount that you cost, then that is the profit. The average per profit per item is this over x. Kind of makes sense. Average divided by the number of items. And then the marginal profit is the derivative. So I give you the s and c. You plug in to figure out the p. Then you can compute the average profit and the
Marginal profits. Okay, everybody?
And then here another story problem. You have d. Okay, so this is the d, and your function r is p times d. So you multiply the p and d together. Okay, everybody? And then marginal value is the derivative of the revenue. Right, everybody? And then you plug in
P is 2. Right. And this one is
displacement, right? Given a displacement, you take the derivative to get velocity. You take the second derivative, you get acceleration, right, everybody?
Yes. And then look at the sign of the velocity. You determine whether it's moved to the left or moved to the right. But how do you know speeding up or speeding down? Slowing down. You look at the sign of directions, same directions. A and B, same direction, speeding up. Opposite direction, slowing down. So not just positive or negative. Okay? And this one, be careful.
I give you p. You need to find p prime. So you need to take the derivative, and then you plug in x is 5. Okay? Same thing here.
I give you Q, and you need to take the derivative, and then you plug in the numbers. And here,
I give you this function. I ask you to find r prime. You need to take the derivative of this, and then plug in the numbers.
okay, everybody? Yeah, and then, yeah, those are the type of problems in exam 2. Okay, next class, we will talk about 5.1. We're still one lecture behind.
It's okay. But I hope you can do well in exam 2. Okay? So do the practice exams.
And if you have questions, come to see me. And homework 4 due tonight.
And homework 5 and quiz 3 due next Wednesday after the fall break.
Okay? Bye.